Good afternoon, everybody. Welcome to class today. Thank you for joining me. Thank you for joining me. Thank you for watching. Whether you're watching live or you're watching the recording, I appreciate you watching. Today we are moving on to Module 6, and in Module 6 we're going to be talking about value methods. And this is in contrast from void methods that we talked about a couple weeks ago. So we're, just adding another tool to our toolbox in terms of things that we can do with our Java programming language that we're working with here. And so with our hour today, we're going to talk about value methods, talk about when we would use value methods, and just do some examples of value methods as we're working through everything. So we said value methods are in contrast to void methods. So let's go ahead and talk about and sort of discuss what we know so far and put that into context with what we're talking about here when we're talking about value methods. So up until this point, right, we've used void methods to modularize our code into different chunks. And when we're talking about void methods here, remember the term method if you're familiar with other programming languages. We could call that a function. Right? So we've been using void methods to modularize our code into different chunks. We said that we write a new method to take a sequence of lines of code that do a particular thing, and we encapsulate them into a singular method. And so when we invoke these methods, code is executed within them. But when we're using a void method, if we want to use some calculations that happen within that void method in another method, one of the things that we've discovered over the past several weeks is that we have to chain our methods together. Right? There's nothing that we can do to kind of save that method or save that value from that method to be able to use it as a part of multiple different calculations or what have you, right? So if we were to jump over to a replit here and just do some simple calculations in terms of all of that, just to kind of demonstrate what we know so far, right? We've been using void methods. And so let's just say, for the point of argument here, right, again, just a really overly wrought example that's just to kind of work as a proof of concept, right? Let's just say we have a function or a method here that takes in two values. We'll bring them in as parameters. We will add them together. And we'll say something like int z equals x plus y. And let's say that we want to take that value and we want to use it in some sort of other function to do some sort of other calculation. So for the purpose of this quick demonstration here, let's say we just have another static function that we'll call, say, double up in this instance, where we will take some integer value and multiply it by 2. So system.out.println x times 2. Right, so the idea being here again, right, we're going to have to encapsulate, we're encapsulating different lines of code into different methods, right? So, we've kind of overly simplified a problem to give us, a peek into a solution here. So we say, okay, I have this one function. The purpose of this one function is to take these two numbers that I give it and add them together. And so that's the purpose of this function. And I need to take that result and I need to pass it to another method that is designed to multiply that value by 2 and print the result to the console. So with what we know right now, the only way that we can get these x and y value, or this z value here out of this add function, is to call our double up function within our add function and pass a parameter into it accordingly. Right, and then note that it's going to take that value in as the parameter, and it's going to print out directly to the console. So even still, right, no value is being saved here. Right, if I wanted to do something with this value, I'd write my method and I would have to chain a method call to this new method inside of my double up method. Right, so what we see here is we see, this sort of string of methods that we have to chain together in order to make something happen. And then when I call this add function, I can call it with, two integers as parameters. Run it, and we see we get 34, right? So it takes in the values 12 and 5. 12 plus 5 is 17. 17 times 2 is 34, and that's the result that we get in the output. And then if we want to take that result and do something with it, we have to add another function, come back here to this double up function, add a call to that function, or add a call to whatever other. Right, and it just gets, hard to do. Right, like let's, we end up with different function calls going to different places, and it can get really, really confusing. Right? Even still, we're not taking these values and storing them anywhere. So if we wanted to use them in the future, or we wanted to use them in different contexts, we couldn't do that, right? Not unless it was a part of what we have contained within that function. And so that's where we're at here. Lost my PowerPoint window. Here it is. So that's in essence what we know right now, right? With our use of void methods. Right? Void methods don't contain any, don't store any values anywhere else. They don't allow us to, take values and use them in different places. They just, we can just call methods from within methods to be passed forward. And eventually we get to a print statement, which sends things out into the console. That's why we have value methods. Right, so value methods are different from void methods in two ways. One is that they declare the type of the return value. So when we create a void function at this point, right, every single function that we've written has been called a void function. When we work with value functions, whatever data type that we will be eventually returning from that function will need to be called or initialized in the method declaration as we're writing our method, right? So when we look at our standard void method declaration, it says public static void, right? Which lets us know that it's a void method. Whereas with our value methods, we'll be doing public static int, public static string, public static double, public static boolean, so on and so forth, depending on what the ultimately returned value is that is coming out of that method. And we need a return statement that is going to be returning the value. So we can include print statements that happen before the return statement, but the return statement is what terminates the execution of the method. So when I get to that return statement, I am fulfilling a promise that I made, right? Because when I declared that method, I told my interpreter, I said, you're going to get this type of data value out of this method. So it's a public static int method. So I'm making this promise to my compiler or interpreter that at the end of this method, you are going to get an integer back. And in the fulfillment of that promise, it stops executing the method, right? So any code past the return method is not executed. We call that unreachable code. Right, in Java, it should actually error out to let us know that we have unreachable code in our method that will never actually run because it's past a return statement. So when we look at a value method looks like this. So we can look at a value method. So in this instance, we see public static double. Public static double. This is that promise that we're making to our interpreter, that we're making to our compiler, that this return result that we have down here is going to be a double. Now, we notice that we're using a parameter here. But remember that the utilization of this parameter has nothing to do with the type of function or the type of method that this is. What is connected to our method type is what is our output. So in this instance, our parameter is a double, but it's only coincidental because we need a double in order to be able to do the mathematic computations that we're doing here, right? Or to have the level of precision that we need to do the mathematic computations that we're doing here, right? Because we're looking at pi times radius squared, so we're looking at area of a circle here. So when we're bringing in a radius, we want to bring in a radius as a double value so we can have the precision that we'd want. What matters again is the return result here. And so let's write this function and let's see what's going on. So what I'm going to do here is I am going to basically write that same function. Let me comment out that add call here so we don't use it. And let's write a function that'll find an area of a circle. And in this case, it will be a value function. And let's go ahead and do it with taking an input, right? So let's just go ahead and write some code here for a minute. We'll take an input here, which means we're going to need scanner. So we're going to say import java.util.scanner. At our class level here, we'll go ahead and we will initialize our scanner object, right, the way that we did previously. I think we looked at this last week or the week before, right? We looked at initializing scanner at class level so that since it's initialized at class level, we can use it in different functions without having to create a new object or do any sort of object-oriented dealios there. So what we will do is we will public static scanner in equals new scanner on system.in. Right, so now we have a declaration of scanner at class level that can be used in any method we write. And so what we could do here, right, just for the sake of argument, is we could do two things, right? Let's write one function that takes the user's name, one function that does the calculations, and then we can put it together in a singular program. And actually, I think what I'm going to do here is remove these other methods that I've written so far, just so this doesn't get muddier than it needs to be. Right, so I want to write some function that's going to get the user's name, and I want to be able to take that value from the user, return it back as a string value, right? So we know here then that I'm going to be writing a string return function here, or a string value function. So this is going to be a public static string. And we can name it, we can say get name. And I'm going to put a string of message in here, and that'll be the message that we use to get to prompt our user for their name. Right, and this is actually something that we could do with an input function like this, is we can actually kind of use this to make sort of an ad hoc input function, like you might be familiar with in, say, Python. Right, that would be essentially the way that this works, is that we have a particular method that takes some sort of parameter that displays that on screen. And then when we have that method call later on, instead of doing everything that's in that method, we can just call the name of the method with the message to our user as the parameter and return a value that gets stored to a variable, just like we were using Python here. Now, one of the things you'll notice now that we've kind of written this function declaration is I got a big squiggle line. Big red squiggle line here under get name string message here. And if I hover over that, I can see what that's all about. And it says this method must return a type of string. So it knows that I made the promise that I'm going to return a string out of this, since I used string as my value method type. So it's expecting to see a return statement in my method that returns some kind of string. And so what we do in instances such as this, just to get rid of our errors, so we can do some testing and things of that nature while we kind of go forward, is we write what we call a stub, S-T-U-B, stub. And a stub just allows us to, a stub contains two pieces, right? It contains the function declaration that we've created here, and it contains a generic return statement that returns some sort of value like what we promised. So in this instance here, I can write my function, write a return with some sort of empty string in it, or some sort of I can write test in there, or I can do whatever. And now I have a stub. And so now that I have a stub, you can see that red line, that red squiggle line goes away, and I can test this program without having to encounter errors going forward. So inside of this here, what I might do is I might system.out.print message take a string name equals new string in.next line. And so now we can pass out name as the return value here instead of what we have in our stub. So now if we wanted to echo this back out, note that this is a return statement and not a print statement. So if we just simply tried to call this method here in main, get name, what is your name? If we simply tried to call this, note no little red lines. It's going to ask me my name. I'm going to type it in here, but absolutely nothing's going to happen, right? It happened on the back end because it returned the value. The value has been returned and it's in memory. But we see nothing happened here because there was nothing to happen here, right? It's just a data value that's just kind of sitting out there, right? It's basically just like if I declare a variable and just say, oh, int y equals 6. And I just do that. I never do anything with it, right? It just does nothing. So that's what we're looking at here. So in order to be able to use that, what I need to do is I need to store the results inside a variable. Or use a print statement to print it out to the console. Right? So if I used, say, a string username equals new string, and then call our function in here. Right? Get name. What is your name? So now, instead of it just sitting out there and doing nothing, it is being taken and stored into a variable container. And so now we can use, say, a system.out.println just to make sure this is working as we would expect it to work, and call our value of username just to see it get echoed back out in the console. We call this process incremental testing. Right? So I maybe don't intend to use the username in this sort of manner to begin with, but I want to make sure this function works, and I want to make sure that it's getting the name and holding it properly, holding it the way that I would expect it to use it. And so in this instance, I can write just a simple print statement here in main to see the results. And so as I run this, we can watch it work. It says, what is your name? I can enter in the name, and we see it echoes the name back out. Right? What is your name? Mr. Ramsey. And then it just echoes right back out, Mr. Ramsey. That's exactly what we should expect here. So now we know that function works. So it's like we said before when we started working with methods. If I do some testing in between writing my methods, I know this method here works now. Right, our method here works. I can put a big checkoff beside it. And I know I don't really need to touch it anymore. And one of the great parts about using this is, I mean, we're using it to get a user's name here. But I don't have to, right? Like, this is a function that can get any string. So if I want to use it to get some other string for some other purpose from the user, I can use this exact same function to that end. Right? You know, just like we said, like you would do with the input function in Python, right? It's the same principle at hand here. Right? I use the function, add a little message as a parameter, and then in turn we use that as, get the return value and put that into a variable. So now let's create another function here, and this will be the double function that we sort of represented in the slideshow there, which is going to be, calculating the area of a circle, pi times radius squared. So we have a function that can get a string text-based input from a user, and now we can get some other values from our user. So one of the things that we might want to do, and it's just a good use case for that, is we might want to system.out.println or system.out.print enter circle radius. Now the thing to notice here, right, the reason why I'm doing this is just to demonstrate using the same scanner in different methods, right? So we can see this happen here. Since we initialized our scanner here in the class level, we can use that scanner here to do that job, but we could also use it in the main function or any other method that we're working with, right? So I can take a value double R equals in dot next double. Right, and then if I wanted to do some incremental testing here and test out the value of R, I can system.out.println R just to see what we've got going on here. So we're not using username here in an output at the moment, but it's still going to go through and it's going to run the function because we've invoked our function here. So it's going to go through, it's going to run that function. It's going to ask me for my name. It's going to ask me to enter a circle radius. And it's going to echo back 5.0. I entered in 5, it's going to typecast and assume a 0.0 there. So it's going to return to me a 5.0. And so now I know that this little bit of code works. And so I can take that value and pass it into another function invocation here. So something that I could do here is I could say, oh, well, we're going to write a double method that's going to take that method and find the area of said circle. So let's create a public static double find area, and it's going to take a double r argument, in this case r being the radius. Now, what do we see here again? We see a squiggle line under find area double, or find area parentheses double r, and it's because it's looking for my return statement, right? So in this instance, I'm just going to go down here. I'm going to add my little return statement, and I'm going to add something like 1.0. Just a double number that it can see being returned. So it knows, okay, promise is made, promise is kept. And so now I can do the math, right? So let's just go ahead and do it the simple way, in which case I can just come in here into the return statement, do the calculation there, which is going to be math.py times math.pow r comma 2. Which I believe that's the right way to have the math.pow r. Yep, that's it. That's going to raise r to the power of 2, so that's radius squared. And math.py is the pi constant in the math library. So we're good there. So now we can do some incremental testing for the value of that, right? So we can system.out.println we can call that function, which we're calling here find area, and give it the parameter of r, which we're also using r here to be that. And we can just do that like that. And this will echo back out to us the radius. So it's still asking me my name, right? Because I still have this function call in here. So I still need to type that in, although it's not doing anything with that value right now. It's going to ask me what my circle radius is. In this case, let's go with something that we can, with some relative certainty, calculate. All right, so let's go with 2 here. Because we know, it's going to be somewhere around 12. Right, because if we go radius squared, 2 squared is 2 times 2, which is 4, times pi, which is times 3.14. Right, so 3 times 4 is 12, so it's going to be 4. It's going to be 12 and a little extra. Right, and we get echoed back out 12.566, so on and so forth. Right, we get that high level of precision there. And remember, if we want to there, we can do the whole printf thing that we've done in the past to handle that as well. Right, which is our formatted string there. So for example, like if I wanted to take that and truncate that to a two-digit number there, I would make this a printf statement here instead of a print line statement. Then inside of my system.out.println line here, just like we've done before, right? It's let's see if I remember correctly. It's going to be percent symbol d percent symbol 0.2n, I believe is the correct way to do that there. We're going to run this now. Still have to run Mr. Ramsey. Circle radius, let's say 2 again. Whoops. I got my format precision just a little bit wrong there. Let's see if I can remember what I need to do to fix that. I think I need to put some sort of number in front there as well. So let's go just like 5.2 there. Oh, I've forgotten my... I have forgotten my syntax. Let's just look up the syntax really quickly. Ah. That was what I did. That's 0.2f. I think I might have been getting the string syntax there. Or some other syntax there conflated with that. I think that'll do it for me in this instance. So now if I do, Mr. Ramsey here and 2, that's better. We get 12.57. Which is exactly what we're looking for. Which is good. So now we know what we're doing here and we can go from here, right? So let's take what we have here so far and let's try to put it together. And we'll even bring in a void function so we can see something that we can do with our void function here. So public static void prog title. So we can create a void function called prog title, and all this is going to do is just print out several title lines. So we'll do system.out.println here. We can just do like a little fancy circle area solver. Maybe do another print line here that's just like welcome to the circle area solver. And so since this is static text that we might want to do several lines of, that we might not want to have it clouding up our main method here, we might just want to put all of these lines of text in their own void function and then just call that prog title function as a part of our main method, and we'll just call that first. Right, so now it'll run that prog title function print out those lines that are in there. And then we can move on to this. So it's going to ask me for my name. And then maybe here under double R equals n.next double, maybe I want to use that username there, right? So maybe I want to system.out.println thank you username. Maybe I can take it a step further, just add a little more information to it. Period. Here are your results. And then just put in here area of the circle. Units squared. After our formatting here. And so this gives us the ability to run this more elaborate type program. So let's go ahead and clear out our console here. Run this program, see what it does for us. Right, so the first thing it does is it runs that function, runs our void function where we just had, those couple of plain lines of text there. Asked me for my name. I'll enter my name here, which is going to be Mr. Ramsey. And then it's going to tell me to enter the circle radius. And let's say in this instance, I want it to be something like 3.8, right? We know that our math works because we used a lesser value, a more easily calculable value to test it out with. So it's all well and good and working. So we can use a more complex value here. We can hit enter there. And it says, thank you, Mr. Ramsey. Here are your results. Area of the circle, 45.36 units squared. Right, and so we've used a couple different value methods in conjunction with a void method here in order to be able to do what we want to do, which is incredibly, incredibly useful. And so that's a good proof of concept there that we can use to see this example fleshed out. So we can talk about some different things here. Let me check my notes to see what else I'd like to do here. Because we more or less covered the majority of the notes that I have. So let me check the rest of my notes. I think in terms of what I've discussed here, right, I think I've said everything that's all in my notes. The only thing that, putting the notes on the screen at this point would be to just kind of add the slides to the video record, which, you may or may not care about. But I think I'd like to take some time here, just try to do a little bit more code to end us up today. So we're actually doing some more code, just writing some more code today. So I've got a coding challenge here for us to do. So let's examine this coding challenge. This is one of those instances where if we were in a seated class, I would show you the coding challenge. I would say, okay, take the next 30 to 45 minutes and try to do this coding challenge, and then we'll get back together and do it. So I encourage you all, if you're watching the recording, to pause the recording after we go over the prompt in just a minute. Try this out. Then come back and watch me do it. Otherwise, if you're here with me live, maybe you want to go back and try it later on your own just to see if you can remember it. But we'll go ahead and do the problem. And so this coding challenge is called Old MacDonald Had a Fence. And it is another one of those job interview type coding challenges that you might encounter. So let's read the prompt here. It says, Old MacDonald had a farm, and on that farm she had a square-shaped pasture. And on that pasture she had a cow that was prone to escape. So now Old MacDonald wants to set up a fence around the pasture, given the area of the pasture. How long a fence does Old MacDonald need to buy? So let's talk about what we know here just based on that. So we know that we have Old MacDonald. Old MacDonald has a cow. Old MacDonald has a cow, and that cow is in a square-shaped pasture. So we know that the pasture is square, which is important for us to know. In the drawing here, it's a little skewed because it's perspective, right? We know that the pasture is square. So regardless of the input that we get, we know that we have both sides being the same. And so we're told that we're given the area, or the square units of this square pasture. And we want to know how to get the amount of fence that we need to go around the pasture. So in this instance, what we need to do is we need to take our area, deconvert it from a squared area to just one side. And so we're in which case we use square root to get that. So we get our input of an area. One side is the square root of the area. And then to get the amount of fence that one would need to go around this pasture here, well, we would just take this one side and multiply it by 4 to get the perimeter of our pasture. So we take our input, we get the square root of the input, we get the side, and we multiply it by 4. So now that we know that, we can head back in and we can start to write a program here. I'm going to make a new Java program for this. And so I know what I want to do here. Right, so I basically want to write, just so we get practice, I want to write 3 methods. One that's going to get the value, one that's going to take the square root of the value, and one that's going to multiply by 4. So let's write, and again, probably overkill, right? If we were doing this in the real world, we might just write 1. And so I tell you what, for the interest of time, we have the other example that we did. For the interest of time today, let's just write it in 1 function so we can get wrapped up here. I would normally write it in 3 functions just so we would get more practice writing value functions. But it's fine, right? We can write 1 here and we can get done with it. So let's import scanner because we're going to need to be able to get the area. Of our farm. Let's do 2. Let's do one that gets the value and the other one that does the calculation. So let's do 1 for public static double get area. We can even enter a message here if we wanted to. So that would be string message. Remember, if we want to get rid of that little squiggle and do some testing, we just go ahead and finish our stub by writing some sort of simple return statement there. We can take a value and just say system.out.print message. Double area equals in dot next double. Getting ahead of ourselves just a little bit there because we haven't actually made our scanner object yet. So let's go back here at class level and say public static scanner equals, or scanner in equals new scanner on system.in. So now that's good and will work. And we can return area. So the other function that we'll need, we'll make another public static double get fence amount. It will need a double value that is the area. So we'll calculate a double A here. So we can say side, which would be a double. So we can say double side equals math.sqrt A double parry equals side times 4, and then we can return parry. So we have our square root function there that gets us the side, the peri variable getting the perimeter variable, getting the perimeter, taking the side, making it all 4 around, since we know that our pasture is a square based on what we were told. It's easy for us to do this. So we can system.out.print. Actually, we don't have to do that. We can create some variable, double pasture equals get area, enter area of pasture. And so then it'll run that get area function, return the area value back. Then that value becomes pasture. Then I can create my, say, double fence amount variable and set that equal to the result of get fence amount with pasture. As the parameter. And then I can just system.out.println you will need, and actually instead of print line here, let's do print f, just so we can have some cleaner values there. And just say percent 0.2f linear units of fence. And that solves our problem, right? That gives us our algorithm that we need to take the area. Let's not forget to put in fence amount here. That gives us the algorithm we need to take the area of our field and get the right amount of fence from it. So we can run this just to see it work, and we can see it work once with something that's easy that we could know. For example, let's say 81. So if we have an 81 square unit pasture, right, then we know 9 times 9 is 81. It's an easy square root that we can do there. Then we should then get back that we need 36 linear units of fence. And in this case, 36.00, because we are doing the formatting here. We need 36 linear units of fence to do the job. So we can see that's what we get on our output. So we know that that is functioning. So we can do something more complicated and say just some random number like 532. And then we can see we need 92.26 linear units of fence in that regard. So that does our job there. And that is basically what we want to cover for today. Pretty simple problem. I'll go ahead and throw that problem back up there so you all can see it. I will send out the first file with the recording today, but I won't send out this file. I'll just, to give you all the option or the opportunity to kind of do it on your own. So you're not tempted to peek. All right, so we'll leave this here. You can pause on this or whatever so you can see it to do the problem yourself if you'd like. And as we go to wrap up here, this is where we will take questions if anybody's got them. So if anybody here with me live has any questions, we can take those now as we're wrapping up. The concepts around value functions are relatively simple. Right, we just want to make sure that we're implementing them the right way with our return statements. All right. Looks like the people here with us today are good. So with that being said, we'll go ahead and wrap up. If you think of any questions later, or if those of you watching the recording think of any questions, send me a Teams message or an email. That's all that I have for you for today. Thank you for watching. We'll see you next time.